This is Advanced Math 12.5 homework questions. That's Advanced Math Unit 12, Lesson 5. These are the 5 problems I'm going to go over, starting off with number 2. And it asked you for numbers 2 and 3 to evaluate the logarithm by using the change of base theorem. You will need a scientific calculator for this, not a baby calculator, a scientific one. Change of base, I went over how change of base works and why it works in notes, so you can look back if you are confused. But the way it works in the end is you do log of 15 divided by log of the base, which is 2. Log, 2 separate logs in a fraction, not one fraction, not a log with one fraction. It's a fraction with 2 separate logs. So you plug them in separately when you plug them in your calculator. Now, I believe I did say in notes that you don't reduce these. Even if it is reducible, you cannot. I don't know if it's going to show up there, but you're going to type in log. Let me just zoom in. Okay, log of 15, and make sure you close parentheses. You have to close parentheses, otherwise it's going to give you the incorrect answer. Divided by log of 2. Now this parenthesis you don't have to close, you can, but it's not necessary like the other one was, equals, and let's round to 3 decimal places, that is 3.907. All right, next one, same thing. I do log of the top piece, log of 0.1 divided by log of the base, and plug it in the calculator. Again, in notes I explain the how and the why that works. Okay, log of 0.1, close parentheses, divided by log of 6, close, don't close, that's up to you, and you end up with negative 1.285, 3 decimal places. Negative 1.285. All right, how you do this next one is up to you. Your Math 3 teachers last year may have taught you one way or a few different ways. I like to take log of both sides. That's me. Some people like to rewrite it in logarithmic form. Log base 9 of 0.045 equals x, and then use change of base. Perfectly fine. I like to take log of both sides. That's just me, because that's what's stuck in my head, the way I remembered it from when I was in school, and for me that way always works. I don't have to, like, which way does the logarithmic way go? Where does the 9 go? Where does the x go? I just take the log of both sides. Now, I'm not multiplying by log, I'm taking log of both sides. Okay, now log of 9 to the x allows me to take the x to the front, and that's the whole reason why I take the log of both sides, to get my exponent to the front. Divide both sides by log 9. Now, if you wanted to, like I said earlier, you could have changed this to logarithmic form. I'll show you really quick what that looks like. It would be log base 9 of 0.045 equals x. Change of base theorem, you end up with this right there. So it's up to you which way. Change it to log form. If you change it to log form, you have to remember what goes where. If you ever forget, just take log of both sides, bring your exponent down, and divide. Okay, let's plug this in right here. Log of 0.045, close parentheses, divided by log of 9. And you end up with not what we should have. I'm going to try that again. Log of 0.045 divided by log of 9. Okay, log of 0.045 divided by log of 9. All right, negative 1.411. Okay, next one, same thing. I'm going to take log of both sides. That's just me. Now, if you wanted to, you could do it this way, change it to logarithmic form. Again, that requires that you remember how to change it to logarithmic form. If you ever forget, you can just do this. Log of both sides allows me to bring the exponent down to the front. Divide both sides by log of 2. And that's what you would end up if you had changed it to logarithmic form and then did change of base theorem. All right, negative x equals, and we're ready to plug that in, log of 5, close parentheses, divided by log of 2. And then I want to get rid, well, let me just write that down. 2.322, 3 decimal places, rounding, and then I'm going to divide both sides by a negative, negative 2.322. All right. Last one, number 13, is a word problem, and it reads, it's off of the worksheet, it reads, if the half-life of cesium-137 is 30 years, find the constant K for which A equals A naught, E raised to the negative KT, where T is expressed in years. I'm going to write that down. So that was A equals A naught, that little zero sub-zero is, A sub-zero is pronounced A naught. A equals A naught times E to the negative KT. All right, so remembering from notes, what is what? A naught is the initial amount. Initial amount. And A is the amount after a certain amount of time. So ending amount, it's the amount after a certain amount of time has passed. And E is a number, it's just a number in your calculator. K is what we're looking for actually in this problem, because it asked find constant K. We don't know what the constant K is in this particular problem. And T is the amount of time that has passed. Okay, so in this particular problem it says find the constant K where T is expressed in years. Okay, so if the half-life is 30 years, so we know the time is 30 years. It gives that to us in the problem. If the half-life is 30 years, find the constant K, that's what we're looking for, where T is expressed in years. Okay, so we know the half-life is 30 years. Now, it didn't tell us the original amount and it did not tell us the ending amount. When that happens, you make your initial amount 1, and your ending amount, depending on what it says. It says half-life, so half of 1 is a half. Now, if it said this is the amount of time it takes to double or triple in the amount, then you would put 1 and 3. Quadruple, 1 and 4. Half, 1 and half. It just depends on the problem. Okay, so I'm going to plug it in. A is a half equals A naught is 1 times E raised to the negative K times T is 30. I'm going to divide both sides by 1. It's not necessary because you should know that 1 is a multiplicative identity. It's not going to change anything. 1/2 equals E to the negative 30K. 1/2 equals E to the negative 30K. Now I'm going to solve it the same way I did on numbers 8 and 9. You can change it to logarithmic form if you'd like. I'm going to take the log of both sides. Log of 1/2 equals log of, and I'm going to take a step back. Yes, I am going to do the log, but, and I mentioned it in notes, I didn't mention it earlier, so I'm just going to jump back to 9 and 10 and mention it here. When you take log of both sides, notice I never wrote a base, and the reason is because it's assumed to be base 10. If you can pick any base in the world, why would you pick base 10? Because base 10 is programmed in your calculator, so that's what we use. So we're doing log base 10 of the decimal, log base 10 of 9, and when we plug it in our calculator automatically works it out with the base of 10. So here, instead of using log base 10, I'm going to use log base e because I'm dealing with an e. So again, I could use regular log base 10, but it's easier if you use ln. So I'm going to take ln of both sides, which is just log base e. So it works the same as a regular log. This is a regular log. It's just log base e, and I'm doing that because I have e in the problem. Okay, I'm going to bring this to the front. Negative 30k times ln of e equals ln of 1/2. Okay, something to think about. What is ln of e? Remember, ln is log base e. So log base e of e equals what? E raised to what power is e? That would be 1. Log base 10 of 10 is 1. Log base 5 of 5 is 1. Log base e of e is 1. So this is a big 1 in disguise. 1 is the multiplicative identity, so I don't have to worry about it. I'm going to divide both sides by negative 30 and plug that in the calculator. Okay, so let's see if I can get this in. Okay, ln of 0.5, close parentheses, divided by negative 30 equals 0.023. So that's my value of k, my constant. K equals 0.023. And that is it for this section of homework questions.